Take an object and place it on the surface in front of you. Okay, now take it away. What's left? No, seriously, what's left? Nothing. Simple enough, right? Now, this next question is super important. What are your thoughts on Jean-Luc Godard's films? Well, unless you are a loser who watches boring movies for fun, you probably don't have any. So, once again, the answer is nothing. How can the answer to both these questions possibly be the same? What even is nothing? The failure of an entity to exist has been generalized into the incredibly useful mathematical concept of the null set, an essential component in number theory. It's easy to see that nothingness is an all-important concept in theory and everyday life. Naturally, we would want to teach our artificial children about this remarkable idea nature imbued us with. Just one problem: nothingness doesn't exist. Or does it? Let's say you're a machine learning engineer whose boss wants you to train a neural network to identify images as either being a cat or a dog. Suppose you throw together a convolutional neural network, train it on some images, and you're done. Now, instead of feeding it pictures of a cat or a dog, you feed it an image of a toaster. What does your neural network classify it as? From the internal perspective of the network, the entire universe is only composed of images, and those images are either a member of the dog or the cat class, and that is all. The toaster will be classified as either a dog or a cat, because surely it must be one or the other. How can we teach artificial intelligence about what nothing is? To do nothing at all, and appreciate that action as different from any other action it is capable of taking? Most importantly, how can we tie all these individual instances of nothingness into the singular core idea of nothing? Cognitive scientist Lawrence Barsalou gives us a possible explanation for our own ability to make sense of nothing. Barsalou posits we can acquire even extremely abstract ideas, like nothingness, through direct experience, and a host of other contributors such as sociality, language, interoception, and metacognition. Taken on its own, this seems like a tall order for machines to replicate. The link between perception and action is an ongoing area of research in technologies such as self-driving, and this is to say nothing about the impact of things such as interoception and sociality. So perhaps nothingness, in general, will remain out of our reach for the time being within artificial intelligence. But what about nothingness within a more confined context? Consider the idea of yuhaku no bai, or the beauty of negative space. This idea is exemplified in Sumie paintings, where the concept of emptiness is heavily leveraged. When a generative model creates a piece of art in this style, does it understand that negative space and paint are inverses? Or is the negative space just another segmented region to be populated with new information? If Barsalou is correct, and humans understand nothingness through experience, can it be understood through self-supervised models, in contrasting art styles, fed directly into a deep neural network? The sorts of models that we have today readily on hand. Or does this kind of understanding require the kind of embodied understanding, the kind of embodied perception that human beings enjoy on a daily basis? It may be possible to gather some insight on how an AI considers this issue using latent space models, but that's a story for another time. From themes in art to a general understanding of information and entropy, nothingness permeates our subjective experience of the world. Arguing by analogy is often tricky, but humans do represent the only general intelligence we are aware of, and we seem drawn to the fundamental dimensions we identify in the world around us. And what could be more fundamental than the distinction between something and nothing.